Welcome to myprojectbazaar.com.
Now we discuss about photovoltaic battery powered DC bus system for common portable electronic device. Renewable energy source based on photovoltaic along with the battery based energy storage power conditioning to meet the load requirements be connected to the electrical grid. The power conditioning is achieved via DC to DC converter or DC to DC inverter stage to produce a desired AC source. This is also the case even when the load is a DC type such as the typical portable electronic device that requires AC adapters to be powered from the AC mains. The latter present a hybrid PV battery powered DC bus system that eliminates the DC to AC conversion stage, resulting in lower cost and improved overall energy conversion efficiency. It is also shown experimentally that the portable electronic device can be reused with the proposed DC bus system. A novel high-gain hybrid boost playback converter is also introduced with several times higher voltage conversion ratio than the conventional boost converter topology. This arrangement results in higher DC bus levels and lower cable conduction losses. Moreover, the voltage stress of the hybrid boost playback converter power switch is within half the output voltage. When a renewable energy source such as a solar power is available and since it is fluctuating DC in nature, the DC to AC inversion followed by DC to DC conversion can be eliminated if the output is DC. Inserting solely a DC to DC converter with maximum power point tracking capability in between the renewable energy source and the load would save the extra conversion loss associated with the unnecessary conversion stages for a DC to DC buck boost powering an array of LEDs from the photovoltaic panels. However, to fit in the renewable energy source, it is costly to again make different DC to DC converters for different equipment voltage. When this equipment case already a switching AC adapter. Moreover, the replaced switching AC adapter will become a harmful waste to the environment. It is therefore attractive to reuse these AC adapters as most of them are made up of switching DC to DC converter. In fact, it is experimentally proven and documented in this letter that the switching AC adapter operates properly with DC input voltage by providing common DC bus. All the switching AC adapter can take power from such as bus to power the various common portable electronic devices. One of the major considerations with solar energy is the intermediate nature, so that it needs some kind of storage typically provided by a battery to be assistant output voltage regulations at all times. A common practice is to adopt a cascade connection of the battery charge and the cover to provide DC voltage for the load. The drawback of this configuration is the rapidly processed input power that regards the overall conversion efficiency. In this process, the PV cell generates the DC output for our grid. If the grid gives enough power for the PV cell and excess power will be go to the battery charging. Suppose the PV cell does not create the power for the grid, then the battery automatically discharges its power and give the power to the grid. For that reason, we use the PV cell and battery to maintain the power quality in grid for maintain the power quality. Here, the battery will be used for charging the wasted voltage from the PV cell and also discharging that wastage of the PV cell to the grid during the power loss occurred in the grid. It is the flow diagram of our proposed work. Here the PV cell will be go to the MPPT tracking. The MPPT tracking is the process to maintain the output PV cell voltage as a pure DC, because the PV cell voltage will be varying based on the irradiation level. And then here after the MPPT tracking it will be go to the feedback signal and then the inverter. Here the switches will be convert the ABC to AC. Here the inverter will be filled to convert the AC into AC current, and the AC will be connected to the grid. Here we get the reference signal from the grid and compare to the reference signal and generate the pulses for controlling the switches. And the switches will be control the inverter for maintain the low frequency and low loss output of AC for control the grid. And here after the before the inverter, the battery will be used for charging the wasted current from the PV cell. It is, and then we give the power from the battery, and the process will be done again and again. The output AC will be getting the low frequency and maintain the power quality on the grid side. Now we go to C of our process. First we getting the source from the PV panel. So first we design the PV panel with generate the voltage with based on the irradiation level. So the irradiation level generate the random of PV output. It is not a pure DC, so it is not usable for the converting process. If the not pure DC will be converting to the AC, then the output will be the low frequency, or the some harmonic will be increases. So that reason we use the MPPT controller with P&O technique for maintain the output PV cell voltage with pure DC. The MPPT control getting the one MOSFET switch and also the controller. The MPPT control getting the output from the voltage and the current from the output of PV cell and voltage from output of the MPPT control after switches, and then the clock and the reference signal. And the MPPT controller generate the pulses based on the input current, input voltage and the clock signal and also the reference signal. So it will be generate the pulses for control the MPPT to maintain the pure DC voltage. After the pure DC voltage will be, then it will be getting the pure DC and it will be interconnected to the battery, and the battery will be connected to the single stage boost inverter. Here the input DC will be boosted to the its voltage level. Here the pulse will be given. The pulse will be controller based on the output PI controller, and then if the PV controller generates a low amount of voltage, then the battery will be discharging. If the PV cell generate the high amount of charging, the battery will be discharging the current, and that boost converter will be controlled based on the output pulses, and then the finally output will be getting the pure DC with boostable, and it will be converted to the use the inverter and will be converted to the 3 base AC output. Then it will be used to maintain the grid voltage at high power quality. Thank you.